Correlation is not just a statistical test you run at the end of a study. It is the analytic expression of a correlational design within quantitative methodology. A study turns toward correlation when the research problem and the literature gap show that two constructs are believed to be connected, but the nature or strength of that connection has not yet been clearly established. The field suspects a connection, but does not yet understand how strong it is, or whether the variables tend to move together at all. Correlation is chosen because the knowledge needed at this stage is descriptive, not causal and not predictive. Correlation is used to examine the relationship between two continuous variables. A relationship means how two measured variables move together, and in what direction. As one variable increases, does the other tend to increase, decrease, or show no consistent pattern? You can think of this like watching two dials move at the same time. Neither dial is causing the other to move, but you are observing whether they tend to rise and fall together. Correlation does not test whether one variable causes the other. It does not test influence, impact, or effectiveness. It simply describes how two variables covary. This makes correlation especially useful when the goal is to map patterns in a field before moving into prediction or experimental work. For a research question to align with correlation, it must include the word relationship. This word must appear in the question itself. Other verbs such as examine, explore, or assess are too vague to signal a specific quantitative analysis. When the word relationship is used correctly, it tells the reader that the study is asking how two variables move together, not whether one predicts or explains the other. If the question uses the word predict, correlation is no longer appropriate, and the study has shifted into regression. If the question asks about differences between groups, correlation is not appropriate. The verb controls the analysis. Correlation requires that both variables be continuous. Continuous variables are measured in amounts, not categories. Examples include test scores, percentages, time, frequency, or total scores created from validated instruments. A single Likert scale item is not continuous and cannot be used in correlation. However, when multiple Likert items are combined into a composite scale score, the result behaves as continuous data and can be analyzed using correlation. Assigning numbers to categories does not change the nature of the variable. The type of measurement determines whether correlation is possible, not how the data are coded. One of the most important conceptual features of correlation is that it is symmetric. This means neither variable is treated as an outcome being predicted. Both variables are measured, and neither is positioned as more important than the other. Correlation does not have a dependent variable in the same way regression does. A useful way to think about this is that if your question can be answered without deciding which variable comes first or matters more, correlation fits. The moment one variable is framed as explaining or estimating another, correlation is no longer the correct choice. A helpful way to understand what correlation sees is to imagine a scatterplot. Each participant contributes 1 point based on their score on each variable. Correlation examines whether those points form a pattern. If the points rise together from left to right, the relationship is positive. If the points slope downward, the relationship is negative. If the points form a scattered cloud with no clear pattern, there is no relationship. Correlation is about the pattern formed by the data, not about explaining why the pattern exists. Correlation relies on several assumptions that matter conceptually. The most important is linearity. Correlation can only detect straight-line relationships. If two variables are related in a curved or uneven way, correlation may underestimate or completely miss that relationship. In those cases, the data may show a real connection that correlation is simply not designed to capture. Outliers also affect correlation in meaningful ways. A small number of extreme cases can pull the relationship in a misleading direction, making it appear stronger or weaker than it truly is for most participants. When this happens, the correlation may reflect the influence of unusual cases rather than a general pattern across the sample, which changes how confidently the result can be interpreted. Distribution shape also matters. When variables are heavily skewed or clustered, correlation can become unstable. In these situations, the direction of the relationship may still be informative, but the exact strength should be interpreted cautiously. The analysis may still describe a pattern, but it cannot precisely represent how closely the variables move together across the full sample. Correlation also depends on having enough data to detect a pattern. When sample sizes are very small, even real relationships can fail to reach statistical significance. In those cases, a non-significant result does not necessarily mean the variables are unrelated. It may simply mean the study did not have enough power to detect the relationship. When assumptions are violated, the study is not automatically invalid. Instead, assumption violations change how confidently the results can be interpreted. They require the researcher to slow down, avoid overclaiming, and be transparent about limitations. Sometimes this means interpreting the relationship cautiously. Sometimes it means acknowledging that the analysis may not fully represent the complexity of the relationship. These are methodological judgments, not technical fixes. The result of a correlation analysis is a correlation coefficient that ranges from -1 to +1. The sign tells you the direction of the relationship. A positive value means the variables increase together. A negative value means that as one variable increases, the other decreases. A value near zero means there is little or no relationship. The size of the coefficient tells you the strength of the relationship. Statistical significance indicates whether the relationship is unlikely to be due to chance, while the size of the coefficient tells you how meaningful the relationship actually is. Consider an example. A study asks, what is the relationship between teacher self-efficacy scores and student engagement scores? Both variables are measured using validated instruments that produce numeric scores. The question uses the word relationship, and neither variable is positioned as an outcome to be predicted. Because of this alignment, correlation is the correct analysis. If the correlation is moderately positive, the study can conclude that higher teacher self-efficacy tends to occur alongside higher student engagement, but it cannot conclude that one causes the other. Another example might ask, what is the relationship between time spent studying and exam performance? Both variables are continuous, and the question asks how they move together. Correlation can describe whether students who study more tend to perform better, worse, or no differently on exams. It cannot explain why that pattern exists or whether studying causes higher performance. It is equally important to understand when correlation is not enough. Correlation cannot answer questions about influence, contribution, or prediction. It cannot establish temporal order. The direction of a relationship does not tell you which variable comes first in time, or which is more important. Listing a variable first in the research question does not give it priority. Correlation treats both variables equally. Correlation is often used in early or exploratory stages of research within a field. It helps researchers map patterns and connections that can later be examined using predictive or experimental designs. It is not a weak method. It is a precise method designed for a specific kind of question. Problems arise only when researchers try to make correlation answer questions it was never designed to answer. When correlation is chosen, that choice should be visible throughout the study, from the purpose statement to the research question to the analysis, with the word relationship carrying that alignment across each section. When used correctly, correlation provides valuable insight into how variables are connected. When misused, it leads to overinterpretation and false claims. The key to using correlation well is alignment. When the research problem suggests a connection, the gap calls for mapping that connection. The question uses the word relationship, and the variables are continuous. Correlation becomes the natural and defensible choice.